Hello, welcome to another tutorial from Smart Learning with Sati. And in this video, we'll be looking at how we can use first principles to differentiate any given function. In the previous video, we derived the formula we use to differentiate any given function with respect to x using first principles. And it looks something like this. Change in y over change in x, taking the limits as change in x tends to 0 will give us f of x plus change in x minus f of x all over change in x. Now don't forget that change in y over change in x can also be called the derivative of the function. Okay, so that means if f of x is the function, what symbol can we use to represent the derivative of the function? We can use the symbol f prime of x. You can check this out in the tutorial we did on the gradient of a straight line, and I introduced a concept like this, and I said we'll be using it more often in trying to find the derivative of a function. So this is where we're going to apply what we've learned in the previous videos. So f prime of x can also be used to represent the derivative of a function f of x. In other words, if f of x is the function, f prime of x is used to represent the derivative of the function. Or you can say if f of x is the function, to differentiate the function f of x is going to give us f prime of x. So that means what the question is asking us to find is the derivative of f of x, which is f prime of x. And how do we go about that? It's simple. So we're going to use this expression here to find the derivative of the function f of x. Solution. We can start by saying let f of x be equal to, of course you know f of x is equal to x squared. Now if f of x is equal to x squared, let us find f of x plus change in x. That's the next step. F of x plus change in x. Now what does this mean? It means that wherever I see x, I'm going to replace it with what? X plus change in x. For instance, I'm seeing an x square here. So instead of x square, I'm going to write what? X plus change in x. This x plus change in x has replaced x. Okay, now don't forget to square it up because there's a square here. Now we have just found f of x plus change in x. The next thing to do is to subtract f of x from this. So you see how we are doing this step by step. So we can now say f of x plus change in x minus f of x, which is this step here, will give us this entire expression we've just gotten here, x plus change in x squared minus, now what is f of x? Don't forget that f of x is equal to x squared, so we can put x squared here. Alright, now before we proceed to divide by change in x, let's first of all simplify this expression. Now this is where some students actually get this confusing in expanding this binomial expression x plus change in x. Now this is how I want you to see it. If you have something like this, a plus b all squared, to expand this, you can simply do a plus b times a plus b, right? Which will give us what? It means that multiply everything in the first bracket by everything in the second bracket. So it's going to be a times a, this a times this a will give us a square, and a times b will give us ab. Then the next one you do b times a will give us ab, and b times b should give us b square. Now if we simplify this further, we should have a square plus ab plus ab, of course is 2ab plus b square. So that's how you expand this. Now why did I bring this up? We are going to use the same expanded form to expand x plus change in x squared. And how do we do that? Now let's say a here will represent x and b here will represent change in x. Please take note, x and change in x are different things altogether. They are different quantities altogether. Okay, so don't think that this x here is the same thing as this x in this change in x. No, they are different. Like I just did here, I said x is equal to a and b is equal to change in x. So let's take them like two different quantities. So if we apply this expansion, we can have that x plus change in x squared minus x squared, I'm just rewriting this expression here, will give us, so if we expand these brackets of x plus change in x all squared, where x is a and change in x is b, we should have x squared, remember a squared is x squared, right? We are just substituting, plus 2 times a, which is x, 2 times x, times, remember b is what? Change in x, times change in x, plus b is what? Change in x squared, so let me write it here, change in x squared. Now minus, remember to put your x squared to minus x squared. So if we go ahead to simplify this, we should have equal to x squared plus 2 times x is 2x, and 2x times change in x is 2x change in x. Now this is where students also get it wrong. Some students think because I have an x here, so I have an x here, I should have change in x squared because x times x is x squared, but that's wrong. Remember I said you should look at the quantities of x and change in x as two different things, where this represents a and this represents b. So 2 times a times b is 2ab, and that's why 2 times x times change in x is 2x change in x. I believe that's clear so far. So we have plus change in x squared here minus x squared. Now we can go ahead to take like terms here. Since we have an x square here, we also have an x square here, and they're subtracting each other, they can cancel out because it will give us 0. X squared minus x squared is 0. So if the like terms cancel out, what I have left is 2x change in x plus change in x squared. Okay. Now so far we've done f of x plus change in x. We've done that already, and we have subtracted it from f of x. What's remaining? Let's go back to our expression. Okay, it's remaining to divide by change in x. So let's do that. If we say divided by change in x, so this means that we are going to divide this entire expression that is left here by change in x, and so it's going to give us 2x change in x all over change in x plus change in x squared all over change in x. We are dividing them individually, okay? And so we can say that change in x will cancel out change in x here, and if we do change in x into change in x squared, we should have change in x left up here. And so our final expression looks something like this: 2x plus change in x, right? Now we are not yet done. There's still one thing we need to do. Let's go back to our expression. So the last step of finding the derivative of a function is to take your limits as change in x tends to 0. So this is one thing you don't have to forget. So how do we take the limit as change in x tends to 0? So if we have the derivative of the function of x, this expression actually represents this entire expression here. So I can just shorten it to f prime of x, and then decide to take the limits as change in x tends to 0. What this means is that this my answer I've gotten here as 2x plus change in x. I'm going to put 0 wherever I see change in x. So just substitution. Substitute 0 for change in x, and I should have 2x plus 0, right? And then my final answer will be what? 2x plus 0 is 2x, and that is the final answer. So this is the derivative of x squared. It means that 2x is the derivative of x squared, and that is how you will find the derivative of a function using first principle. In the following segments of the tutorial, it's going to get more interesting because we'll be looking at several examples on how to find the derivative of these functions with respect to x using first principle. So I hope to see you in the next tutorial. Thanks for watching.